Dr. Neil McRoberts, an associate professor at UC Davis. His presentation is entitled A Historical View of Red Leaf Viruses in Napa County. Please join me in welcoming Dr. Neil McRoberts.
I'm sorry that I can't be there in person to speak to everybody in Napa this morning. I'm in DC for the fall on a teaching secondment, so welcome very much to the students who are in the room with you today. And it's great to hear that there are students here in the audience to hear about this historical perspective on these two diseases. And I'm going to pick up on a few of the themes that Caleb mentioned in his introduction. So I'm just going to start my timer here to keep me on time. I know we had a little bit of a delayed start this morning, so hopefully I won't ramble on too long, especially if my good friend Mark Fuchs is going to be speaking later on. So if you're in the audience there, maybe I'd encourage you to take a note of my email address now on this title, from the title slide, because I'm going to refer back to it later on. I've got a couple of requests for you this morning, and one of them might involve reaching back out to me after the end of the talk if the offer I'm going to make to you sounds of interest. So if you're interested in helping us with a survey that we're doing, please take a note of my email address so that you can reach out to me after the talk's finished. So I'm just going to give you one more second to do that and then move on to the next slide. So when Ben contacted me to participate in today's workshop seminar, he mentioned, of course, that the topic was about rootstocks, and he said that he'd like me to give a kind of historical perspective of red leaf diseases in Napa County, so to set the scene for some of the more detailed technical information that's going to come later during the next few talks. So I'm going to mention rootstocks a couple of times, but I'm not going to go into a lot of detail about the role that rootstocks play in the way that virus diseases express themselves, or what can be done through rootstock selection, maybe to mitigate their effects. I'm going to leave that kind of technical detail for later speakers. I'm really going to just give a very broad overview of epidemiology of these viruses as that relates to the North Coast region. I'll talk a little bit about work that's been done in other areas of California as well. But I am going to emphasize a couple of the themes that Caleb's already mentioned. And I'm going to start the story by using this slide, which I've borrowed from my colleague Mahir Al-Rawani from Foundation Plant Services at UC Davis. And really our story begins with this idea that for resilient, high quality wine grape production, we should be thinking in terms of this mantra of get clean, stay clean. And of course, clean here refers to being largely virus-free. And the way that the industry has for a long time invested effort in trying to hit this target of getting clean and staying clean is through investment in supporting Foundation Plant Services, the Clean Plant Program at a national and at a regional level, and starting production with certified planting stock. Predating my arrival in Davis in 2010, of course, the nursery side of the grape industry was larger than it is now. There were more players in that game. There was a bigger diversity of nursery production types and operators, and partly through I guess, natural selection in the business world, and partly through increasing demands for higher quality and better stock, the nursery industry has contracted down to a smaller number of relatively effective players, most of whom I would say are very much on board with the idea of certification and the idea that that word certified has to have a meaning in order for it to be something that everybody can have trust in. But one of the things that I quickly realized when the late and sadly missed Deborah Galino recruited me to work on grape virus epidemiology, one of the things that we quickly came to realize was that there was a misunderstanding in the industry about what certified means. And in case that misunderstanding is still present, what it doesn't mean is guaranteed absolutely 100% virus free. So that's not an achievable objective in the way that the nursery increase system is operated in California. Certified doesn't mean guaranteed virus free, but it should mean that you have a guarantee that there'll be a maximum tolerance level of the amount of virus that you can expect in material that's purchased under the certification label. So no guarantee of virus free, but there should be an acceptable level of virus presence. And obviously, what we hope is that the nursery industry is always operating to try and exceed the standards set by inspection to be virus free. And essentially, when it comes down to it, for practical purposes, what certified means is that we're operating at a level where if we can't find the virus after inspection, we're certified. And if we find it readily, we're not certified. So it comes down to the effort expended in going out to look for it. When we're thinking about material being increased for sale. And I'll talk a little bit about some of the intricacies of how that works, but that's effectively what we mean. So what we're trying to do is make sure that we see as little as possible of these, essentially, of these two viruses. As Caleb mentioned, of these two, leaf roll's been around probably far longer than red blotch. Certainly, the awareness of red blotch as a disease started after my arrival in Davis in 2010. No, I didn't bring it with me. It was here already, as research on herbarium specimens showed. But red blotch has been around for, let's say, a decade or slightly more now, at least in terms of being something that we're worried about on a large scale. Leaf roll's been around as a large-scale problem for more like 5 or 6 decades, if not longer. Leaf roll virus, of course, vectored by various species of mealybugs and soft-scale insects sometimes, and it has accelerated and perhaps resurged as a problem in the region with the arrival of the vine mealybug as an invasive species. Because of the larger number of generations that vine mealybugs have per year, there are more opportunities for the juveniles to acquire the virus and move around and spread the virus through vineyards. So the rate of spread of leaf roll 3 has accelerated as vine mealybug has progressively invaded California, entering new grape production areas. And going back to the sense of frustration that Caleb referred to, I think we can trace at least some of that frustration to the fact that vine mealybug has really taken off in California and has made it more difficult for us to get ahead of leaf roll as it spreads in vineyards because it's a more active vector than our indigenous mealybug species. So while VMB, vine mealybug, has been expanding its range in California, concurrently with that, over the last 10 to 12 years, we've seen an increase in the second red leaf virus, red blotch virus. The vector relationships for this virus are still a little bit of a mystery. It's not 100% clear at the moment exactly which species of insects are involved in vectoring red blotch in different locations. the known for certain vector in some cases is, of course, the three-cornered alfalfa hopper, or TICA for short. But there may be other membracid species, other tree hoppers or leaf hoppers, that may also be capable of vectoring the virus in some circumstances, and our entomology colleagues are working hard on trying to pin down exactly what the vector range is, what range of vectors there are in California. Is it just TICA, or are there some other species that may also be involved? So our two main enemies in terms of rapid spread of virus disease in California vineyards are leaf roll and red blotch. Those are two big culprits. So thinking about the challenge that the industry faces, one of the ways, I'm just looking at the slide in the room there on this presentation slide, waiting for it to update before I say too much. One of the ways that I talk about epidemiology with the students in Davis is to think about it as us having to play a game against nature. And it doesn't make the problem easier to solve, but it's a way of thinking about the situation in which we find ourselves. So we can ask ourselves, if we're playing against nature in some kind of competitive game, what is the game that nature's playing, and what are the rules of that game? What is she doing in terms of how the spread of these viruses is happening, and the speed at which it's taking place? And then, if we're kind of on the other side of this game, what can we do to try and make sure that we win the game if we can? And in order to illustrate how that can work, we use these simple simulations that we do in spreadsheets when we're teaching in the epidemiology class. And the reason I wanted to refer to those is that I hope you can see that the patterns that emerge in these games. If somebody kind of blurred that out a little bit and told you that it was an aerial image that had been taken from a remote sensing drone, or a fixed wing aircraft or something from a high altitude, you might be willing to believe that that kind of patchy pattern of red and green and yellow was not unlikely to have been generated in a vineyard if leaf roll was spreading. It's a little bit stylized, but what I wanted to illustrate was that we can think about ourselves as being in this two-sided game against nature, and she's trying to do one thing, and we're trying to do the opposite. We're both trying to win. And what we know from thinking about these things as a game is that we're going to see some familiar kinds of patterns emerge, both in space, so across the surface of the vineyard. If we look down on it, we're going to see kind of characteristic patchy patterns of virus expression emerge as the disease progresses. But if we look over time, we're also going to see these kinds of signatures generated if we're willing to wait long enough. So if we're looking at either one of these diseases spreading over several seasons, we get these familiar what are called logistic disease progress curves, where it kind of goes up in a sort of S shape. If you squint your eyes at it. And then if we look at the number of new infections that appear each season, we get this kind of hump-shaped curve where somewhere around the middle of the epidemic, we get a big increase in the number of infected vines. And then as the remaining healthy vines go down in number, the epidemic slows down again. And this would be the curve that we heard so much about when it came to flattening the curve during COVID in that public health setting. So we have the same idea in plant health as well. The disease starts off slowly as more infected vines are available to generate more virus inoculum, the epidemic accelerates. It ticks along in this middle phase when we reach the peak. And then as we run out of healthy vines to infect, it slows down and the rate of infection drops off. And so it turns out that the rules that we can think about for how that happens in simple games that we can play in the classroom really apply quite well to what happens with leaf roll epidemics in real life. So going back to around 2013, 2014, so a decade ago, Carrie Arnold, who was a PhD student with me and with Deborah at Foundation Plant Services, worked on that idea. And what we did was gather up all the data sets that we could find in literature where people had made a note of how many infected vines there were over time in different places around the world. Several studies had been done in Italy by a research group there. There was a nice study from our colleagues in Auckland in New Zealand, from their white wine grape growing area. And then there were data available to us from Napa, from a collaborating vineyard, and then finally a data set from South Australia. And when we plotted all of those data sets out together, we could see that there was a real range in the speed at which leaf roll epidemics happened. What we've done here to get these straight lines is take those S-shaped curves that we were looking at on the last slide and stretch them out to straighten them out so that we can fit a line through them to get an idea of the average speed. And if you look at across those different data sets, then we can say that the per annum, so the season by season rate of increase ranged from only 4% per year to as high as 20% per year in that Auckland site, which is indicated by the black triangles there. The average percentage increase per year was around 11%, 10.8 across all of the data sets. And Oakville, where the data that we had available from Napa were collected, was right around that average. So it was almost bang on the middle point from the studies that were available from elsewhere in the world. So if there's anything that we could think of as a typical leaf roll epidemic, it happens right here, or right where you are today, in the North Coast region of California. So we saw from that early work that that the speed at which leaf roll epidemics happen changes from place to place, and that depends on things like temperature, which determines how active the vectors are, topography, sometimes which choice of varieties and rootstocks there are, and a whole range of other things, including, of course, how hard the growers are working to stop the disease from spreading. But when we analyzed the spatial pattern of how a leaf roll epidemic increases, all of those different data sets fell on approximately on this nice curve. So to get this curve, what we have to do is map out where the infected vines are in a vineyard, divide the map up into groups called quadrats, and then we basically count how many infected vines there are each season in each of the quadrats. And what you're looking at here is a curve where on the horizontal axis, on the x-axis, we've got the incidence of infected vines. So that's just saying what fraction of all of the vines in the vineyard are infected. And on the vertical axis, you've got a similar scale, but instead of asking how many vines are infected, we're asking how many quadrats have at least one infected vine in them. And if a quadrat of 4 vines has one or more infected vines in it, we call it infected. And when you plot those two numbers against each other, the proportion of infected vines versus the proportion of infected quad rats, you get this nice curve that captures the spatial signature of leaf roll. And you can see that although, if you think back to the last slide, although the speed of the epidemics was different in those different locations, ranging from an increase of 4% per year to an increase of 20% per year, they're all going up the same curve. It just makes a difference how quickly you go from the bottom left-hand corner where you're starting clean to the top right-hand corner where you're completely infected. But every vineyard is basically on a trajectory on this same curve. And of course, what we want to do is, if at all possible, keep everything down here in the lower left-hand corner of that curve. So we want to hem the disease in as much as possible so that it doesn't spread across the whole vineyard. So when we had done that work and Carrie had come up with this nice result that there was a signature, of course, we put the work out for people to read. But what that has allowed us to do actually is also to think about how red blotch compares with leaf roll, because having come up with the methodology to characterize what a leaf roll epidemic looks like, we know that that's being driven by the dynamics of the way that mealybugs move around. And we know about the biology of mealybugs and how they live and how they spread and the way that the crawlers move from vine to vine along the cordons, as well as having some airborne phases where they either get picked up in gusts of wind or they get moved around by other means. But predominantly they're being spread vine to vine to vine by the movement of the mealybugs physically. So that signature is what gives us this curve that I've been telling you about. But that gives us a reference point when we're trying to think about red blotch and thinking about the characteristics of the way that red blotch moves in comparison with leaf roll. And I want to highlight here our efforts to try and make a good thing out of a pretty bad thing, which was, of course, the discovery of red blotch at the Russell Ranch Foundation vineyard a few years ago. So what we're looking at here is a kind of compilation, as well as some aerial photography of the way that red blotch very quickly, once it had been detected, spread throughout the Russell Ranch Foundation. Of course, one bright point in that story is that the greenhouse unit for the foundation has now been completed, and the first cohort of material has been moved indoors completely at Foundation Plant Services. So Russell Ranch has been superseded. Sorry, I clicked to move ahead there too soon. But I still want to highlight what we've been able to learn about red blotch dynamics by studying the disease as it overcame the foundation vineyard. So the figures on the right-hand side that I'm highlighting with the pointer at the moment, those show you in the top half, those show you the observed spread of the virus through the block area, and you can kind of relate the shape on the stylized diagram there over to the aerial photography on the left. And then in the lower plot, you can see some output from one of the versions of a model that we made to try and capture the dynamics of that spread process. And we were able to kind of capture those dynamics pretty well. Of course, we don't predict every vine turning red with red blotch with 100% accuracy, but we get the rules pretty much right in what we've done, and that confirmed pretty early on that in comparison with leaf roll, what we see with red blotch, at least in comparable locations to Russell Ranch, is that the spread is more dispersed than we see with leaf roll, and that, of course, probably comes down to the fact that the leaf hoppers, the tree hoppers, sorry, have a different biology than the mealybugs. Their feeding behavior and their dispersal behavior, carrying the virus around with them, is not the same as mealybugs. They're more active and they move further as vectors, and the consequence of that is the blue line here on the plot. So this is the same idea again. We're looking at plant incidence on the horizontal versus quadrat incidence on the vertical. The blue line is the data from the leaf roll epidemics that we analyzed previously, and the data points are for the red blotch epidemic at Russell Ranch, and the red line is our best estimated line from the data, and the black line up above shows you what the relationship would look like if you took however many infected vines there are at each time and scattered them at random entirely across the vineyard, as if they were dust that you could sprinkle from above. So what does that tell us? It tells us that, at least at Russell Ranch, the red blotch epidemic is somewhere between as dispersed as you would expect if it was a completely random process. It's not as aggregated as you would expect it to be if it was a virus that was being vectored by mealybugs like leaf roll. It's somewhere in between, a little bit closer to where leaf roll is than completely random. So that kind of helps confirm the idea that this is a virus, the red blotch virus. This is a virus being vectored by a set of vectors, maybe just Tika, maybe others, but they're more active. They spread more rapidly and more over a wider distance than mealybugs typically do. Okay, so I'm going to talk a little bit about some history here, which pertains to the Napa region. And apologies for the awful formatting on this slide. I grabbed this out of an old presentation, and it obviously hasn't translated too well. After we'd kind of pinned down the dynamics at the block level, one of the things we wanted to do was look at the distribution of the virus across the region as a whole. And so we asked for participation from the industry, and we structured a survey that Carrie did, and some of you probably participated in that, where we looked at different eras of planting in the Napa and North Coast region. So we essentially identified 4 eras of planting, and I suspect if we were to repeat this exercise, we may well have had a 5th era since we did this survey. But the 4 eras were material that we called heritage material, that dated from some of the earliest plantings in the valley, dating back to the end of the 19th century, right up to the early 1980s, so covering a whole 100-year period there. Then there was the 81 to 95 period, which was really when AXR1 failed. The phylloxera epidemic saw to that. So there was another planting boom from 96 to 2010. And we attributed that planting boom to, as it says on the slide, rootstocks that were being replaced because they had been used, and what we were seeing was the emergence of virus symptoms that had previously been masked due to the widespread use of AXR1 and St. George before the phylloxera outbreak. And so that's one of the points where I am going to refer to rootstocks, just to make this point that some of the epidemiology that we see at a big scale, definitely over the long term, definitely has been connected to changes in planting and changes in the rootstocks that have been widely used by the industry. And the recent sudden vine collapse epidemic that we're seeing may well have a similar, or at least part of the story there may well be similar, in that there may be a rootstock effect involved in that one too. And then our most recent epidemic is in the most recent planting period was from the 2011 to 2014 period, which was a resurgence in planting that happened after the end of the 2009 economic recession, when I guess confidence in the industry resurged. So to quickly walk you through this slide, there's a lot of information here. Each row is a different virus, with red blotch at the top. Back in the day when we made this slide, it was still called red blotch associated virus, thanks to Mark. We don't need to use associated anymore. Then we've got 3 leaf rolls, 1, 2, and 3, and then grapevine virus A, B, fleck virus, fan leaf virus, and then down at the bottom our control virus, rupestris stem pitting virus, which is not part of the certification program. And the main thing to look at is that so the vertical scale in each of these little blocks shows you the number of blocks out of the 100 that we surveyed where different levels of virus were found. And what the very final column shows you is that, with the exception of red blotch and leaf roll 3 and a tiny little bit of grapevine virus A, all of the other viruses were completely absent from the survey material, a little bit of fan leaf, in the most recent material. So the most recent planted material, when we did the survey, material that had been produced through the certification program, had no virus in it. The only viruses that we were able to detect on a regular basis were the ones that had known vectors that moved them around. And at the point when we did this survey, red blotch virus wasn't even in the certification program. So it's not a surprise that we were seeing blocks that had an appreciable level of red blotch in them. And here's our warning for where we are today. Even though the certification program was operating effectively at that point, we were still seeing countable numbers of blocks with leaf roll virus in them, because it's hard to stay on top of a very mobile virus by using clean planting material only. And so that really, that result, together with seeing, as this slide shows, that you can have mixed infections of multiple viruses at the same time, depending on how old the material is. Those results really told us that start clean really isn't enough, and that you've got to stay clean as well. So here's Carrie actually doing the survey, the initial survey, and then on the back of the utility of those results for the industry as a whole, and the PD board put up some money for us to extend the survey approach out to the rest of the state. And here's Kamyar Aram, who took over the work, sampling some vineyards down in San Luis Obispo as part of the statewide survey. But the results, they are largely confirmed what we already knew from the North Coast work that Carrie did, which is that really certified material has extremely low levels of the viruses like leaf roll 2 or some of the other viruses that can't easily move around. Once you get them out of your planted material, they don't come back. But for viruses like red blotch and leaf roll, as Caleb noted in his introduction, we have this ongoing battle, because they're out there already, and they can move around. So even blocks that start clean have issues with staying clean. So let's move on to that part of the game that we're playing against nature. What about the stay clean piece? And this is where we get into a really knotty or gnarly problem, right? Where we're interdependent on each other to try and achieve that result. In our kind of simplistic way of thinking about a landscape with vineyards in it, with production blocks in it. We can think of it like a mosaic where different blocks with different statuses are under the control of different vineyard managers. And each vineyard manager may have a mixture of healthy, green, definitely infected, red, or maybe infected or somewhat infected yellow blocks. And of course, in a situation where everybody's managing their own little piece of that mosaic on their own, and with highly mobile viruses that can spread around, then an infected block doesn't necessarily only pose a threat to healthy blocks within the same property, but the virus can easily cross property lines and be a threat to blocks on neighboring properties. None of this is news to anybody, I'm sure. So the principle of area-wide management or neighborhood group management is to think of not think of managing the virus on a property by property basis independently, but to think of a neighborhood of blocks that are collectively being managed by a team or group of people. And if we then think about the neighborhood as a whole, we can think, how do we keep the virus out of the neighborhood, or how do we manage the neighborhood more effectively so that most of it is remote from any possible sources of infection? So we trying to take the battle to the margins of the area rather than thinking about how we fight it internally from one property to another. And if that practice is pursued for long enough, then we have a very good example from South Africa and another one from New Zealand, where this approach, applied over fairly large scales, has succeeded in reducing the level of leaf roll 3 virus quite dramatically under their conditions. So there's some hope that over time, a neighborhood approach gradually leads to an increase in the proportion of completely virus-free blocks that are in the area as a whole. And of course, that means there's less inoculum in the area as a whole. And so there's less disease spreading around. And so everybody's efforts to benefit from replanting with clean material gain from everybody else's efforts to do the same thing. So very much something that relies on the idea of cooperation. This kind of idea becomes a problem under circumstances that we understand pretty well. And the main situation where we're going to have issues with this kind of problem are where the disease has a high potential for spread, but it's not everywhere yet. And that's the highest risk area. Why is that? Well, because it can get everywhere. So everywhere is potentially at risk. But if it's not everywhere today, then there's a possibility for different people to take different attitudes towards management, depending on what their own circumstances are locally. And that comes down to human nature. Some people by nature are cooperative, other people less so. And there's not necessarily a direct correlation between the kind of level of cooperation you're comfortable with and where you happen to be in relation to where the disease is. So we spent some time trying to understand that, particularly in the Napa area, and we did a Q we did this to look at people's attitudes, and many of you will have seen these results before. So we produced a set of statements that were about leaf roll and virus management, and then we ask people, basically, we write those statements on cards, and we ask people to put those cards on this kind of pyramid type board, where at one end people can put cards that have statements on that they strongly agree with, and at the other end they can put cards where they strongly disagree. There's lots of possibilities for putting cards in the middle where they neither strongly agree nor disagree. And we get a whole bunch of people to go through that exercise and sort those cards out. And what that reveals is the breadth of opinion about the problem. And once we understand the breadth of opinion about the problem, then we can start to do some work, hopefully, to try and fix that. At this point, I'm going to stop briefly and ask you for your help if you're willing to give it. We're currently doing a similar exercise to this to try and understand people's attitudes to organic production, not just in grapes, in organic production generally. So we're running another Q study. And if you would like to participate in that Q study about organic farming, then please email me and we'll arrange to have a sort board sent to you electronically that you can fill in the comfort of your house or the farm office. We can do this online now. Back in 2014 when we did this, we did it in person. Carrie literally drove around with a big piece of cardboard with squares drawn on it, but now we can email one out to you. So if you'd like to help us out with a survey on organic farming, please email me after the presentation and we'll arrange for a Q method board to be emailed to you. I should say that project is part of a larger project we're doing with the Agriculture Commissioners, CACASA, and with CDFA to look at pest exclusion and the state's needs for more investment in pest exclusion across the state as a whole. So if you'd like to help us out with that important project, then please do get in touch. What did we find, going back to our leaf roll Q sort, what did we find? Well, not surprising to anybody who understands human nature, we found that people are different from each other. They have different attitudes to the problem, and also different attitudes when it comes to even thinking there may be a problem. And we can label people in relation to those attitudes. So our collection of respondents for the leaf roll survey was a mixture of we think of basically 4 types of people as shown here. The key point is that any neighborhood group of people or any group of people who try to cooperate to solve a problem is probably going to contain some mixture of people like this. And even other specific issues aside about why they might find it difficult to come to consensus, it's just really difficult for people who fundamentally have a different approach to problem solving to cooperate with each other. People who are what we can say prescriptive by nature tend to want to shut discussion down relatively quickly and move on to the next problem. Whereas people who are explorative by nature want to keep discussing and thinking of more possibilities and keep extrapolating outwards. And so just by nature, if you have people of this type and that type in a room together, they just find it difficult to kind of accommodate each other's styles of thinking about problems. So before we even get down to thinking about the nitty-gritty of any specific issue. Sorry, was there a question in the room? No, okay. So one upshot, again, of historical importance when we're thinking about this question comes to what do people actually agree on. And so if we look at all of the statements we handed out and then look to see where there was the biggest agreement, and I'm not going to go through these in detail, but you can see if you just quickly cast your eye over those, where we saw the largest levels of agreement was encouragingly around the question of the fact that we should do something about the problem, that certification was useful, that virus testing was needed, that there was a key role for the nursery industry to play, of course, in helping people get off to a clean start. It was interesting the extent to which the grower community was more than happy to give the nursery industry more work to do, while at the same time being somewhat reticent in some cases to take more work on themselves. But one thing that I think we have been able to do is to get people to think about how to collect samples if you're going to invest money in testing vines to see if either of the viruses is present, then thinking about where to collect the samples in relation to the overall shape and size of the vineyard to optimize your investment in testing has been something that we've made some progress with, I think, on an extension side. So if anybody would like refreshers or wants some advice about anything connected with the sort of physical elements of how to collect samples, where to take samples, how many samples to take, please get in touch. We're more than happy to help individual management companies or individual vineyard owners think about how to optimize their sampling. And here's a case in point from a Napa vineyard that asked us for help with sampling for red blotch a few years ago. So multiple blocks, the total property around 120 acres. You can see we collected different numbers of samples in different places, and the numbers of positives are shown here. And you can see I've highlighted a few results in red here in the red box. And the point I want to make here, though, is that you should go into the idea of sampling with realistic expectations. You quite often end up less certain about the world after you've sampled than before you've sampled. So please don't go ahead with the idea of investing a lot of money in sampling and testing, thinking that you'll definitely end up more certain than you are at the moment. That may not turn out to be the case. So if we look at these three sub-blocks that are sampled here, dividing the total effort that was available, and we took two quadrat samples in each block. In each case, we found one positive vine, and because these are such small samples, but still relatively expensive overall, you can see if you look over here at these two columns here, the lower bound of estimated virus incidence for the block as a whole is just over 2%, but the upper bound is nearly 80%. It's over 75%. So with very small sample sizes, you don't get very certain extrapolations from testing. And partly to overcome that problem, also partly to allow us to cover the ground faster, and also to just increase the amount of sampling going on as a whole. For the last couple of years, working with our good friend Stephanie Bolton from the Lodi Wine Commission and Lisa Finke from Canine Detection Services in Fresno, with money from the Department of Pesticide Regulation, we've been running a pilot project to train dogs to detect leaf roll 3 and vine mealybug crawlers. And the numbers here I just wanted to show you are the average results for over 2 dogs in each case. So there are 4 animals involved, 2 that are trained for leaf roll, 2 that are trained for mealybug detection. And you can see here the averages across both dogs in both cases and across both indoor, outdoor, and field conditions, that they're achieving accuracy values that are comparable to lab level accuracy, but they're doing it in real time in the field. And the project's now at an end, the pilot project's now at an end, and the question for the industry is whether this technology is something that's worth investing in as a commercial enterprise. If not, then the animals will be retrained for other things. But we're just at that difficult point with any new technology deployment. The research phase is finished, and now we're thinking, how do we go to commercial deployment? So when I get back to California in December, I'll be meeting with Stephanie and Lisa to decide what the next steps are. Just wrapping up. I think the research community, again, echoing Caleb's point about the fact that there's frustration out there. The National Academy just reviewed the PD Board's research program on viruses, and as part of that, I was asked to think about where some sources of frustration might come from, and this is just a personal take on where we've been for the last decade. I would say there's probably been not enough emphasis on the extension side because behavior change requires sustained interaction. And then on the research side, I think if I was to point a finger at the UC and our other research colleagues like Mark who've helped, we maybe haven't been good enough at taking a systems approach and linking the epidemiology to what happens in terms of quality. We sometimes haven't always listened maybe to the questions that you guys have been asking us, although I think we're pretty good at that. Given the key role that behavior plays in deciding outcomes, I think we've invested a lot of money in the kind of the technology science. We haven't maybe invested as much or enough in thinking about how to help with the kind of economics / behavioral side of things. And then just over the last couple of years, maybe not so much for Napa, but in other areas, there are some real economic challenges for the industry in terms of oversupply and low prices. And then, of course, no matter what we do, we're still going to have to deal with the issue that that practices and objectives vary from place to place and person to person. Last thing I want to do is just highlight these two national programs that are very much invested in helping the grape industry in California and elsewhere. As Caleb mentioned, I'm the director of the Western region of the National Plant Diagnostic Network. Maher is the Foundation Plant Services Director. FPS is part of the National Clean Plant Network. You can see where all the different grape centers are here. So California benefits and the Davis region benefits from these two programs being headquartered at the Davis campus. Both of these programs are supported by funds that come from the Farm Bill, if we ever see another Farm Bill. It's interesting being here in DC right now talking to people about that. But if you're speaking to legislators or local people who have some influence over funding, then drop a word for us in terms of supporting the NCPN and the NPDN. Any goodwill in that department would be very much appreciated. Thank you. And then with that, I'll finish. And if there's time, I'm happy to take any questions from the audience.
Any questions?
So your approach where you look at the individual vines that are infected versus vines in quadrants is interesting. Have you then looked at roguing out and strategies that we do and how that affects that curve? It seems like that curve would be the standard unmitigated infection rate, and so you would look at different strategies for controlling the disease and then see how that disrupts your curve.
Yeah, so it's a great question. And yes, you're right. Most of the data sets that we were looking at there, the vines were left in the ground. With red blotch more than leaf roll at Foundation Plant Services with the Russell Ranch vineyard, because of its status as the foundation vineyard when the red blotch epidemic took off there, it was 100% rogued in terms of every known infected vine was taken out for the first few years. And then once that got to the point where it was clear that it wasn't really slowing down the epidemic, Maher, and because it was so costly to test every vine every year, Maher made the difficult decision to stop doing that. It's surprising how little difference it makes. I think to get to the gist of your question, it's surprising how little difference it makes to the overall kind of statistical outcome if you do or don't perform that practice.
Thank you. Any other questions? Going once? All right. Thank you so much, Neil. We really appreciate your time and expertise.
Thank you. Have a great day, everybody.
Hopefully you can hear the claps.